Hey everybody, we have week 17's experiment ready for you. We're going to show you what we're going to do and how we're going to do it and the science behind it. So this is really a cool experiment. We're going to use iodine. This is, we just got some cheapo stuff, Equate, first aid antiseptic. It says 10% povidone iodine. So the mixture that we're using, when you look at it, it's kind of like a brownish, kind of like a dark reddish orangish brown. So the particular mixture that we have is a little bit darker than maybe some other stuff that you might be able to buy. And what we're going to do is we're going to test for starch inside of different substances. So we're going to take a potato. Everybody's going to have an apple. Everybody's going to have an apple. Everybody's going to have a Yukon Gold potato, a red potato. We're going to take some saltine crackers. We're going to have a little bit of some cheese. We'll have some chips. And we got lots of boxes of this Tiny Toast cereal that our family really doesn't like. So have at it. Destroy a whole box of it. We're going to put the iodine on it, and we're going to see if the different items, if they change colors. Now, if they change colors, that means that there's starch inside of one of those different things. So, obviously, off the top of our head, obviously bread has starch, so we're going to see that that's going to change. But you want to ask the kids what they think has starch in it. We know potatoes have starch. Apples don't have starch. Cereal would have starch. Chip, depending on what type of chip that you would have. This is a corn chip. I don't know, it may change a little bit of color because you can get corn starch. I don't know how it's going to change. I actually don't know. We haven't tried it out yet. And then we have some cheese, and then we have these little tiny toasts, so I'm sure something will happen with those. Now, kind of the cool thing of why it changes color. Let's go ahead and just give it a try. So we've got some iodine right here. Go ahead and bring the camera up close. We'll show it to you on a piece of bread. So I've got iodine in my eyedropper. We're going to drop it on this bread and watch it soak in. It should look blue. Is it looking blue? It's hard to tell in the light.
Yeah.
Kind of looking blue a little bit.
Maybe it's too much.
I don't know. Well, let's try it on the cheese. Let's try it on the cheese. Or
just a drop.
Let's do a drop on our cracker here. It doesn't seem to be soaking in. We'll try a drop on our potato. Try a drop on this potato.
We should probably use the vials.
Oh, there we go. This one did turn blue. This is blue. Look at it. It just needed a second to dry. Pretty cool.
It's a little dark. It's difficult to tell.
Maybe we should re-record it with a flashlight. It is hard to tell, but you can definitely see that it definitely turned blue. This is for sure blue. It's just a very, very dark blue. Extremely dark.
Well, don't.
Maybe we'll just put one drop and see it. But some of them, you can distinctly tell that it didn't do anything to some of them. So, like the cheese is very white. You can see that it remained brown. The cracker, you can see it's blue.
Oh, that's true. When you hold it up next to the brown, you can definitely tell the difference. So it is more of a dark blue.
This one turned blue.
How about we get...
These ones turned blue.
Let's get a test tube and some water.
So, we're going to take some iodine, and I'm going to drop it just into some regular water. You'll be able to look and see. Let's shine the flashlight on it so you can see it a little easier.
Should I get closer?
It's a little dark. It's like a brownish color. Okay, you can kind of see it there. Now we're going to take the iodine and we're going to put it in this one, which we put a cracker in there. So it definitely has some starch down inside of there, and we'll watch, and it should change colors. Should change the water to be a blue color.
Water.
Yeah, it could be. Or maybe we should smash it with something.
Well, you kind of got to shake it around a little bit.
There we go.
Ooh, there we go.
Oh, nice and blue. Pretty cool. See how it's like a bluish color? And this one's definitely a brownish color. Well, it did that over here with our bread. Our bread, it's hard to tell because it's actually such a dark blue. It's a really deep blue, pretty blue color. This cracker, it's really deep blue. What we did this first time is we took the straight iodine and then we watered it down. So what's actually in our cup right now is half watered down iodine, and you can see it's a little bit lighter blue. You can see it a little bit better over here on this cracker, or excuse me, chip.
Yeah, you're too close with the flashlight. You can pretty much see the difference when you hold it up next to something that doesn't have starch. Yeah, so you can see the brown in contrast.
Brown and black in contrast. These potatoes are slowly soaking it in. You can kind of see that there is starch in there. These guys turned black. There's a lot of starch in them. Now, the cool thing is, the reason why this is all happening is because stuff on the molecular level is happening. That is making the colors, making the bread change to, or the things with starch in it to change to the blue color. Starch is actually a linear chain of glucose, and it lines itself up, and it's called amylose. And what happens is the iodine comes in, the amylose is actually shaped, it's called a helix. Our DNA is made of a double helix, so it's like two spirals wrapping around each other. But a single helix, you could imagine it being taking a piece of ribbon and wrapping it around a pencil and going in a spiral down the pencil. And then if you were to remove the pencil, if the ribbon would actually stay in that shape, that would be a helix. So what this chain is, this starch chain, is glucose. And it is, it's like this long helix chain that the iodine actually goes and it gets itself inside of that spiral. So if you can imagine, if you could pull the pencil out of that ribbon spiral and you could put iodine inside of it, the iodine would actually go and it would sit inside of it. It's actually what happens on the molecular level is kind of complex, but when light shines down, so like my flashlight, or light from the lamps that we have around here, when light comes in, the way that we actually see color, when you look at my shirt is black, so light is actually being absorbed into the shirt. There's not very much light being bounced back to your eyes. There's actually a special term for that. I can't think of it off the top of my head, but you're actually taking the electrons, and you're exciting them to a different level of intensity. They're like running around, you're all happy and excited, and then stepping on some hot coals, and then you're like running around really fast because your feet are burning on fire. Light can be moved to different levels of intensity. When it's at different levels of intensity, our eyes see that those different levels of intensity as different colors. So what's happening is the light is coming into each of these different objects. The light's coming into just the plain iodine, and we see the brown because the light goes in, and the light is energized in a specific way to where we see the color, that kind of orangish brown. Now, when we infuse starch into the material, or we drop the iodine directly onto starch, the iodine is going in, and it's like, you could think of it like little round balls going in between this spiraling chain of molecules, and it's changing the way that the light hits that particular chain. So the light hits the ball one particular way and bounces back to your eye, but the light's going to hit a chain a different way and bounce back to your eye Just the same, when that ball is inside of that chain, the light's going to hit it a completely different way and hit that, and that light that comes back to your eye is going to be this dark blue. Depending on how much iodine you have in there, and depending on how much starch is in there, you're going to have different shades of blue. And just the same, you're going to, depending on how much iodine and how much water you're going to have different shades of that orangish color that iodine is. So that's what's happening with our iodine experiment. Kind of cool. You can go and drip iodine on all sorts of different things and see if there's starch in it. And if it changes the color to blue, you know that there's starch, because that iodine is actually combining itself with the starch molecule. It's actually going inside, and it's becoming, it's kind of like it's becoming a different molecule. And the light comes in, it shines on it, and it hits it, and part of it bounces back to our eyes. And that's the blue color that we're seeing.
Awesome. And you can test your snacks.
Oh, yes.
The kids can test their snacks.
They can put it in a starch.
And they can make a hypothesis and a guesstimation in terms of what may have
starch.
What may have starch, what may not have starch. And they can test their snack, or you can allocate some of the cracker and the cereal and the potato and the apple, and they can kind of make it a guesstimation if you so choose.
Amen.